Hello, students. Welcome to today's lecture on electric vehicles and technology. In today's lecture, we are going to discuss about electric motors used in electric vehicles. So, electric motors are the heart of electric vehicles. They convert electrical energy into mechanical motions, which helps the electric motor to vehicle to run. So, in today's session, we will be discussing about how different types of EV motors are used in EV and understand how they work. And we are going to compare their performance and see some real world examples. So, let's get started. First, let's understand DC motors. A DC motor has a starter, which is the stationary part, a rotating armature, and a brush with a commutator. So a brush helps to change the direction of current so that the motor keeps rotating. The main advantage of using a DC motor is it is easy to control its speed and it has high starting torque with good which is good for initial movements, and also it is very simple in construction and highly reliable. Uh, for example, like pushing a bicycle, we need to have a strong push at the start. That is the only major thing we need that concerns about DC motors. But the limitation is that the brushes, which makes the system more bulky and they wear out easily, so it needs maintenance, and also it is less efficient at higher speeds and also produces more heat. So DC motors are simple but not widely used in modern EVs. Now let's move on to AC motors, which are widely used today. The main motor is that is commonly used in AC motors are the induction motors because of its simple design. It has a stator and a rotor. The stator creates a rotating magnetic field, and the rotor tries to follow it, but never fully catches because this difference is called slip. The difference between the rotor speed and the stator speed is called the slip. Think of it like chasing a moving train. You will follow but never fully catch it, right? That is the concept behind the slip. Next, three-phase motors. These motors are very good in operation. It gives smooth rotations and it reduces vibrations. But the thing is that it requires sophisticated algorithms to optimize the efficiency across the entire operating range. The main benefits of using an AC motors for EV application is that it has high efficiency up to 95%, and also it works well at high speeds, and it supports regenerative braking, and you don't need brushes, so low maintenance is needed for AC motors. So AC motors are powerful and durable. Next comes the BLDCs. As the name says, no brushes. So instead of brushes, it uses electronic switching. So it has sensors to detect its rotor positions, and also it has controllers to manage the current flow. So we have unless like conventional DC motors, the BLDC motors have electronic commutations. So we have electronic pressures, which means it incorporates sensors and controllers to test the job of brushes. The main advantage of BLDC is that it has high efficiency, which is of the range 90 to 95 percentage, and also it releases less heat. And as there is no pressures, it is very compact and very lightweight and requires no maintenance, and no brush wear and tear are also possible in BLDCs. So BLDC is like a fan with remote control, very smooth and efficient operations. These BLDCs are widely used in electric scooters, drones, and in small EVs. Next comes the permanent magnet synchronous motors. It is one of the most advanced motors, PMSM. The key idea behind using a PMSM is that it uses permanent magnets in the rotors, so no need for external excitation. The main advantage is that it has very high torque density, compact in size, and it gives high efficiency, which means more power in less space. The main application of PMSM is that it is used in high performance EVs, particularly in luxury electric cars, and also it finds application in hybrid vehicles like a powerful sports car engine in a small package. So PMSM is used in high performance EVs and luxurious vehicles. Now let's compare all motors. We look at efficiency, power density and torque density. From the graph it is observed that PMSM gives highest torque and efficiency. The next is the BLDC, which provides good balance at cost and performance. Then the AC induction motors, which is strong and highly reliable, and DC motor is quite simple but outdated one. Now let's see what are the selection criteria for EV motors. We have a wide range of EV motors for EV, but on what basis we can select these motors? So choosing the right motor depends on several factors. First is the vehicle requirements, which incorporates speed, torque, vehicle weight, and also high efficiency, longer battery life. So these also considered while selecting a motor. Next comes the cost. The initial cost and maintenance also plays a vital role in selecting the motors for EV. And then certain environmental factors like temperature, climatic conditions, where we are going to use this motor, at what conditions, environmental condition it is going to operate, that also matters more while selecting a motor for EV. And finally is the integration part, because we choose a particular motor but the space available might be less, so we need to consider that. So space availability and compatibility with battery and controller, that also plays a vital role in selecting the motors. So the motor selection is a balance of performance, cost and efficiency. So let's see some real world case studies. So we have Tesla Model 3 cars. These case studies reveal what type of motor is being used in these type of models. So the Tesla Model 3 cars uses PMSM rear type plus induction motor at the front. So it combines efficiency and power of motor. So Tesla uses dual motor approach, which combines the efficiency of PMSM and the power of an AC motor. Next is the Nissan Leaf, which uses PMSM, which focuses on affordability and efficiency. Then BMW i3, a quite trending brand, which uses PMSM with hybrid magnet design. So its innovative approach reduces the rare earth content while maintaining the performance. So it uses advanced PMSM, which is lightweight and efficiencies. So different companies choose motors based on their goals. Now let's look at the future trend of EV motors. New technology, like there are more updations in motors. We have axial flux motors, switched reluctance motors. So these motors are being used in the upcoming EVs. Axial flux motors are more compact, whereas switched reluctance motors have no magnets. And material innovations. These motors, certain motors use rare earth elements. So these material innovations provide way for reduced energy loss, better magnetic materials, and also efficiency improvements, which is based on artificial intelligence. So, AI based controls, advanced electronics are also used to adapt to driving conditions, and these integrated motor inverter designs minimize conversion losses also. And also, cooling systems. Direct oil cooling enables higher sustained power output, and also these cooling systems provide better heat management. So, future motors will be smaller, smarter, and more efficiency. Now, we have come to the end. Now, let's test your understanding. First, observe each questions and try to give the answers. Okay. Which motor type offers the highest torque density? Of course, it is the PMSM. What is the primary advantage of using a BLDC over DC motors? It is the electronic commutation, which there is it avoids the availability usage of brushes. Which type of motor does Tesla use in Model 3 real axial? It is PMSM. So mostly in high performance machines and luxurious cars, this PMSM is being widely used. What about the efficiency of AC motors? It offers 90 to 95% efficiency. Question 5. Which factor is not a key motor selection criteria? Vehicle color, yes. So let's recall. So today we have discussed about what are the different types of motors and what are the selection criteria for selecting a motor for EV and what are the future tips. So we come to the end of this video. Thank you for watching. See you in the next lecture.